Okay, so let's start to continue the second part of the Padlet CSA2. So if you are using the WIA32 folders, they have the library functions which help you to do some input-output display. And we'll look into the first examples, the dump memory. So if you want to call the library functions of the WIA32 folders, you can just using the call instructions. So the call instructions followed by the library function you want to use. So basically it's just like a procedures. You call a procedure out to run those coding in the procedures as the one we learned in instructions and architectures lectures. Before you call the library functions, you must pass, sometimes you need to pass some parameters to the library functions so they only can know what are the things you want them to do. Okay, so let's copy this dump memory. Okay, then we copy, put it into this Visual Studio. Then just start the debug mode. So let's restart again. So right here, then the first one is offset, means they want to get the initial location of the array you want to show. So in here we're using this array values. So if they offset, then your ESI will become 46,000 here. Then the second one, they use a length of how many elements you want to display in the dump memory call. Okay, so we just simply use the number of element here, so we can just use length of. Then the EBX is, you need to tell them the types or the size of each element. Okay, then the EBX become 4 because due to the D word, so means you want to display something starting at these locations and you put into ESI, the starting location you put into ESI. Then how many elements you want to display is put into ECX. Then the size of each element you put into EBX. So this 3 register is fixed. You cannot use any other register because this 3 register is used by the dump memory coding here. Okay, so let's say we call the dump memory. Then you can see they are displaying there's some error here. So after you call the dump memory, if you open up this execution windows, you can see they display the memory values for you. They will tell you which location you display, then the content in the memory location starting with this one. Then each data they want to display is a byte D word 4 bytes. So they display for you 1 until B, right? Okay, so you can try to change the byte the size you want to display. So let's say if let's say now you want just display 1 byte for 1 element, then you can try to change to 1 byte, then you run the coding. Okay, debug it again. Okay, then you run through the coding and you call dump again. So they will display in 1 byte only. Okay, 1 byte by 1 byte. So at the end, they cannot display all the data in your array, right? Because your array is 4 bytes. Now you're asking them to display how many elements? The length of is A and B is 11 elements. Then each element is 1 byte, so that's why they display starting at this array locations 0, 1. Right, so let's look into the array. So you put the array is a D word, remember. So when you put in the array, there's 4 byte for 1 values, so it should be 0, 0, 0, 0, 0, 1. Then this is 0, 2, 0, 0, 0, 0, 0, 0, only 0, 3, right? This is the value you should have. Okay, Then they're starting at 46,000 locations, right? So I show in the 46,000 location here. Because using the length of and put into ECX, so you are going to display 11, 11. Okay, then the offset is the starting location, so the starting display at 46,000 start location. Okay, then the size is the size you use is 1 byte for the size. So they will display 1 byte by 1 byte starting from this location. So this is the first byte, then this is the second byte, third, fourth, fifth, sixth, seventh, 8, 9, 10, 11. So this is the thing they're going to display in your array. So that's why it's matched with the one you can see is matched with the one in this array here, right? The size you define 11, starting location will define the size of each element 1 byte, right? So this is the functions of dumb memory. So the second one we will go through is the read char. This is the command to get one character and store in the AL. So again, the same thing, you copy this one and put into the Visual Studio Basic. Okay, so you put into the Visual Studio Basics, then you put into the debug mode. So first of all, I just want to clear the EAX, so I'm using the 0 into EAX. So when you call the read char, okay, this window will pop up. They are asking the user to key in certain things. So let's say I type in the value A capital, then you can see your AL become 41 here. So which means the input key in by the user will convert to ASCII code. So in ASCII code, the capital A is equal to 41. So that's why they store the 41 in this AL locations. So this call function is something getting the input from a user, and they will only store in the AL. So everything you want to get the characters from, you need to go to AL to check what are the values actually is the user key in. Okay. So after the read chars, they also the read decimal. So for read decimal, the decimal values they are stored in the EAX. So they are the same thing. You just call the read decimals, then the whole values of the decimal is stored in the EAX. Okay. Let's quickly go through this one. Okay, so I copy into here, and let's say I straight away debug without I straight away start without debugging. Then they will pop out the window. When I first run the code, they will call the read decimal. So I need to key in the decimal. Then I will press, and what if let's say I key in I key in 5, okay, one single decimal, and so it will store 5 in the EAX register, right? So the whole EAX will use to store the values in this register. Okay, so there's total 32 bits of value you can set for the decimal for read decimal functions. Okay. Then the third one we're going to go through is the read hexa. So read hexa also the same things. They are reading the hexa numbers you key in, and they are stored inside the EAX register also. We can copy this one. So the same thing, we try to debug. So start without debug. Then when they run the code, the first thing is to call the read hexa. So you can key in the hexa A, B, C, D, E, F. Then I press enter. You can see the value of the key in is A, B, C, D, E, F, all in hexa, right? Maximum is up to F. So the value of the key will put into the EAX register. So that's if let's say you want to give the full range, you just press 8F, F. It's the maximum values you can key into the EAX register if using read hexa. Okay. The next one is read integers. So for read integers, they are reading the integers values, 32-bit sign values. There are 32-bit sign values. You can key in the negative values or the positive values. They will convert it to two complements and store in the EAX. Okay. So the same thing, after you copy, you start with without debugging. Then they will ask you to key in the integers. So let's say I put 1, 2, 3, 4, 5. And press enter. They will convert it to a hexa number. So here is a hexa number 3039 equals to 1, 2, 3, 4, 5 here. Okay. Or maybe you can try with a key in the negative number. Try to have a look. If they press negative 6. So negative 6 is equal to FFFFFA. So they are converted to the two complements when you key in the negative values. And they are stored in the EAX also. So the read decimals, read hexa, and the read integers all are stored in EAX. Only the read char they will store in AL. Because a character is only 1 byte. So they are using AL to store the character you key in. Then we go to the next one. Should be the set text color. Yeah, you can set the text color if you want for the display purpose. You can try to change the color. Then there's a color code. There's a color selection here. You can just put in all the color in this color selection. Okay, this is a color you can use. So you put into the Visual Studio, then you start without debugging. So you can see you are changing the text, the font color to white, and the background to light green. Okay, so this one is for the font, this one is for the background color. So that's why the font become white, the background become light green. Okay, so you're just using these formulas, but you're changing the name here, then this is enough. Then you can call the text color. You bring this thing into EAX. Okay. So the next one is a write binary. Okay. So yeah, this one is starting to output something. Before this, we are getting the input from the user. All are read, right? We read. The computer want to get the input of a user on character, decimal, hexa, and integers. So now it's starting the computer output something. Computer want to write out something to the user. Okay, so we copy this right bin. Okay, then we put the code here, and we start without debugging. Yeah, then they will display out the binary you use. I haven't changed back the color just now, so they keep in this color. Okay, so we do again, debug, start without debugging. Then you can see, yeah, the display here, right? The number you display in a binary 1, 2, 3, 4, 6, A, F, and 9. So this is a binary number 1, 2, 3, 4, 6, A, F, and 9, right? You are using the EAX to write out the binary number 1, 2, 3, 4, 6, A, F, and 9. Okay, you need to put something into the EAX, the value you want to display, then only you write bin, right? Then they will display out the binary number you want to display. So the maximum is also is based on the 32 bits of your EAX, the values you can display. Then the next one, let's try to do another one. Just now is binary. Then you can try with the integers also. Just copy. So this is for right integer. Same thing, start without debugging. Okay. Hold on. So let's do it again. It's not pop up. Yeah. So this is a window. So you can put in the value you want to display. So let's say I want to display -25556. I can using the right integers to display out the values. I just need to key in it into the EAX. Okay, then they will write out the values if I call the right integers. Okay, so the call CRRF is basically give a space, right? There's a space after your display. Okay, then we do the next one. The next one is starting to write out a string. Right, the last one output is to starting to write out a string. Okay, to write out the string, you need to have the string you want to write. Right, this is the string you want to write. You just put it into this form. Then using the byte. Okay, every string or every character they're using byte, so you must using byte to assign to the array. So let's say this any variable you want, then you're using this way to enter your string. You can key in the string you want, then a comma followed by a 0. You must have this 0 so that they only can know where is the end of the string. Okay, they're using the 0 to let you know that is the end of the string, to let the computer know that is the end of the string. So the thing they need is they need to move the starting location of the string. So that's why using offset prompt put into EDX. So that is the thing you need to let the write string function know only. You just need to let them know where is the starting of the location of the string you want to display and put into EDX register. Okay, then you just debug, start with the debugging. Okay, then start with the debugging. You will get enter your name, right? This is a string to display out, right? So you can change it to other things. So let's say I have other things I want to display. Computer system architecture. Okay, I just type in the string I want. Then the same thing, I just need to offset. So again, let's say I copy everything. I want to display 2 string. I just repeat this code, but in here using the prompt 1. So then they will display this thing for me. So let's start. Okay, I don't know why they cannot put out the first time. Yeah, so you can see the first time is enter your name. Then I call the clear CRLF. They will space go to the new line, then display the second one when the second call write string, right? So this is how you display a string by using the WIA1003 folder. Okay, then the next one we can go to write hexa. Okay, it will be the same as how you read hexa, how you read char also, right? It's the so write hexa means you're writing the hexa output. So let's copy this one. Okay, copy this thing and put into my. So we put into your Visual Studio. So let's say start without debugging. Again, start without debugging. Yeah, they will come out the values you want to write, right? So you just need to put in the hexa value you want to display in the EAX. So the same as a read hex, you can using the EAX, the whole EAX, to display the values you want, right? Then you just type the write hex instead of the read hex. Okay. Then the next one is a write char. So I think I don't need to go through this write char. It's the same as a read char. Instead of getting the value into AL, but you're the one who put the values into AL. So let's say I want to display capital A. I can put A here. Okay, or let's try this one. Okay. Copy it and put it into here. So if you put in this form, they can also display the A. If you don't want, you know the hexa number 41H is equal to A. The ASCII code for A, you can put 41 hexa also. So let's say let's see, is it display the same thing as we want? Yeah, so you can see if they are using the ASCII code. So if you know the ASCII code, you can just put 41 hexa. They display the A for you also, right? So for write char, it's the same. You need to put into AL. They only display the character for you. Okay. Then the next one is write decimal. Write decimal also the same. Using the EAX to write out the decimal, you put in the decimal value you want to write, then you just call the write decimal. Okay. Then the next one is go to X. Yeah, this one is just changing the cursor location. So let's copy this one and put it into here. Okay. Start without debugging. Then you can see they are this yeah. So first thing I call dump register first, right? So that's why they display the register for you. This is the call dump functions. They will display all the register and also the status bit for you. Then I will move my DH10 and DL20. So these are row and column values. So you move in the row and column values into the EDX register, the DH and DL. Okay. Then you just call go to. Then you will move your cursor into this location specified by this row and columns. Then after that, I just display a string ABC only, right? This is the way I display a string. Move EDX, offset colors. Then I call write string, right? Color is ABC. So I just write the string ABC out. Okay, this is just to move the cursor to the certain location you want. Okay, so the next one, let's go to so the next one we will try the is digit function. So this is a function to check your string whether the values in the string, the content of the string is a digit or is it a characters. Okay, so let's copy into this one. Then let's start without debugging. Yeah, this is the thing they display. So first of all, I will move the string into my AL. So I'm bringing a TWO. So basically I'm bringing T into my AL. So a string is a byte. So every location, every character is 1 byte. T is 1 byte. W is 1 byte. 0 is 1 byte. So when I bring in the string, this one into the AL, so I'll bring in the first byte. So which is the T. T will come to AL. So in ASCII code, your T is equal to 54 hexa. So that's why it's bringing 54. Then I will call its digit to check whether the byte I bring into AL is a digit or is or not. If it's a digit, then it will show as 1. If it's not, then it will show as 0 in your 0 flags. Okay, this is your 0 flag, ZF in this display here. Okay, the ZF 0 flag in the status flag will be equal to 0 if it's not a digit. Then I do again, I call down register, I move my second string, the string 1, which is a digit 2 into AL. Then I call its digit again. After that, I check the value of my flag is set to 1 already, the 0 flag, right? So this is the function to help you to check whether the inside the string, that character is a alphabet or is a digit. So the same in my AL become 32 when I bring in the string 2. 2 means in ASCII code is 32, right? So that's why it is 32 here, right? And we look at the second one. Next one. So the next one we will do read string functions. Okay, so this read string, I expand it. So they're basically reading a string into your computer. So you copy the code into your Visual Studio. Then this one we try to debug. As in the palette mentions, the EDX is the location where you want to store the string you read from the user. Then the ECX is the size of the string you want to read. So this is the way to start up an array. So buffer is a byte array. Then how many elements inside? Is 15 elements inside. Then you just put the DUP and you can start up with any values you want. So in here I just define it as 0 initial values. So I will create an array which is have 15 bytes and all are 0 at the beginning. The initial value is 0. Okay, so this DUP is a fixed words. You cannot change the name. Buffer is a variable, so you define the size, then followed by the values of a number of elements in the array 1. So in here they put 15. To show this function, maybe I change it to 10. Okay, so then let's decode. We'll start debugging. Yeah, then they will ask pop out the window. Okay, so let's say I step through first. Then I will come to call string now. Okay, I will come to call string now. They will pop out a window to ask me to key in the string. So I key in 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, right? So it is more than 10 elements, right? This is 10, 11, 12, 13 elements. So I click enter. So what you see in the memory is just store up to 39 only, right? So in this functions, they will always store less one number, one character as you define here. Okay. So you put 10, they will store only 9 elements for you. Okay. So this function is in this way. The ECX is define the size you want, how many elements you want. Okay. So if you look, your ECX is A. So suppose you have 10 values, but they only have 9 values here. And the one who tell you how many elements inside is your EAX. EAX will tell you how many elements you have stored in the location you define. So I define the location EDX is 46,000. So they will store in this location 46,000 starting, then by storing each byte So the string is a 1, 2, 3, 4, 5, 6, 7, 8, 9. Then the A, B, C, D, E, they cannot store because there's only 9 elements allowed due to the size I set in ECX. So let's say I want to store everything. I might change the code to 15 so that they can at least store 14 elements, right? So let's step through again, then I call string, and now 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D. Enter. Yeah, so you can see now they store everything for me. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D. Right, I store everything inside the array. Then they will tell me there's a D. D means what? There's a 13 elements inside, right? So this is how the function of read string. You define where you want to store the string into the EDX. Okay, give the memory location you want to store the string you want to read, and then the ECX is how the size of the string you want to read. If you don't know how big the string, you can just set a bigger value so that they can store more string inside the memory locations. Okay, so this is the read string. Then the next one, we will start to try to how to write a file where you can store in your computer. So let's copy this one and put into the Visual Studio. Okay, copy this file. So basically there's two call here. One is a call create output file. So this will create output files in your project 32 folders. Then you must give the file name, right? So the file name you put into the EDX. So the file name is this one. I define the file name as a new file .txt, right? The file names, you define it. Then you put it into the EDX, the starting location of the file name, right? Then you call the create output file. They'll create output file with these file names. The next one is you need to put the values of you want to put in the you want to write to the file. Okay, so this is the offset buffer, which is this one. Okay, so this is the starting locations of the value you want to write. Then you must tell them how many characters you want to write into the files, into the ECX. So the buffer size in here that equals to 5. So then you want to write 5 characters into the files. And where is the thing you want to write? It start from EDX here. So this is the two parameter I need to pass to this write to file function. So if I debug and start without debugging, okay, then actually I'm writing 41, 42, 43, 44, 45 is a A, B, C, D, E, right? Then if I check my project 32, you can see there is a one new file name come here, right? So this new file name is ABCDE, right? So this is how you create a file in your project folders. You create the output file first, then followed by you write something to the file. So you can set up how many things you want to write by setting the buffer size into the ECX, then point to the location of the data you want to put into the file. Okay. And the next one, let's go to the bottom one, the random one. We don't want to go through. Yeah, we are starting to use the message box. So you copy this code. So you copy the code into your Visual Studio. So it's very simple. You need to have the captions. Okay, the caption of the message box and also the text inside the message box. Okay, these two put into EBX and EDX register. Then that's all. You can start to call the message box. and they will give you the result whether I click yes or no. If I click yes, they will store 6 in your EAX. If I click no, they will store 7 in your EAX. So let's start with the debugging. Yeah, so you see there's a the message pop up here. Okay, the caption is survey completed as the one in here. Then the question is thank you for completing the survey. Okay, then I go to a new line. Would you like to receive the result? If I click yes, yeah, the 6 will be stored inside your EAX. So if let's say I do it again, if I click no, your EAX will return 7. Okay, so this is the way you can create the message box by using the core message box. Okay. So the next one is a simple message box. Okay, it just display a message for you only. Okay, then you copy the code to Visual Studio. So you copy it and let's start in debug. Okay, so they'll pop up this box for you. The same, the caption is dialog, put into EBX, then the message you want to pop up, you put into the EDX. Right? So you just click. This is just a simple message box to tell you something. There's no selection for you, so there is nothing you're going to read from a user. Okay. Okay, so I think that should be all the things you should learn from this CSA2 palette, which is useful for your lab assignments. Yeah, so I think that's all for the CS2 part.